All right, in this video, we're going to talk about triangles. So we're going to focus on the different types of triangles and mainly the angles in those triangles. All right, so we're going to use some of the concepts that we've seen in the last couple videos, but we're going to apply them to these different shapes. So the first thing I always like to touch on is these are the four things that you need to know by the end of this video. So we're going to define the relationship between the angles in the triangle and what they are. Solve for a missing angle, define an isosceles triangle, and use the definition of an isosceles triangle, set up an equation. All right, we're not going to have a lot of equations in this one, maybe just one, but the concepts are what is most important here. So the first thing, let's talk about the three different types of triangles. There's a fourth one that I'll probably add on the bottom here, but the main three. A scalene triangle has three different side lengths and angles. Okay, so it's just going to be a triangle in which all three of these things, or all six of these things, are different. Okay, the sides and the angles are not going to match. Okay, an isosceles triangle has two sides that are the same, and two, we call them congruent base angles. So the way that works is you have a triangle in which two sides are the same. The way that we like to say the base is the side that is left out. This is our base. And the other way we like to look at this is if this is the congruent, these are the congruent sides, then these must be the congruent angles. Right? That's the way that we kind of remember it. It helps us remember that which angles based on the picture. You can draw these things in if they're helpful on the diagrams, kind of whatever you need to do to fill that out. Equilateral triangle has three equal sides and three equal angles. So in that case, all of these are going to be the same, and then all of the angles are going to be 60. The little bonus triangle, we don't really see too many equilateral triangles just because there's nothing really for us to solve if we know all of the angles are 60 degrees, but it may be attached to something that will help us out. But the other thing here, the little bonus triangle, is a right triangle. Okay, a right triangle has one right angle. Okay, so we have a right triangle. Okay, it can be facing anyway. We do have some other types of triangles. I think we have an obtuse triangle, but we might talk about that in the next video or in class. All right, most important thing in this video right here is the theorem for interior angles in a triangle. The theorem is that all three angles in a triangle must add to 180 degrees. That is the most important thing. So angles in a triangle add to 180. So these three angles, 85 plus 50 plus something we don't know, must make up 180 degrees. So 85 plus 50 is 135, and then subtract 135 from both sides, and the angle in question is 45 degrees. But it's very, very important. If those angles do not add up to 180, then it is not a triangle. Something is not right. So this is something that comes up a lot in this class. You'll see it throughout the year with different topics. Right? I have three more examples to do. One of them has a little bit of algebra in it, and the other one has some isosceles triangles and some concepts that we have to work on. All right, so next question. Solve for x and each individual angle. So again, if I know, or if I'm looking at this shape here, it is, in fact, a triangle. And the rule says these three angles must add up to 180. I can set up my equation. I can use 3x minus 5. Let's see, 3x minus 5 plus 2x plus 10 plus x plus 25 equals 180. And from here, I can simplify and solve. So we have 3 plus 2 plus 1 is 6x. And then we have our minus 5, our 10, and our 25 So that would be 30. Let's see, plus 30 equals 180. What we're going to do from here is we're going to subtract 30 from both sides. And we get 6x equals 150. And we get x equals 25. Again, because of this question, that's only half the work. It does say solve for each individual angle. So we'll plug that 25 in. That's going to be 50. Up here, we'll do 3 times 25 minus 5. 3 times 25 is 75. Minus 5 is 70. And 2 times 25 is 50. Minus 10 is 60. So that would be our individual angles. You can use your calculator for that if you need to. If you're more comfortable, you can write all of them out. If that's easier for you, you can do that. All right. Next question. Solve for the missing angles in the diagram. Again, what am I kind of looking at here? I only have one angle this time. I don't have 3 things. I'm always looking for key information when I go through these questions. These 2 marks is very, very important. These 2 marks mean that these 2 sides are congruent, which means we have an isosceles triangle. So if you look back at the definition of an isosceles triangle, we are going to have 2 angles that are exactly the same. The way that I look at this picture to help me remember that is these are the 2 sides that are the same, which means this has to be the base. Remember, this is going to be our base. That means the base angles, if this is 70, this also has to be 70. The base angles are congruent in an isosceles triangle. And now that I have that information filled out, I can do that all 3 angles add to 180. So 70 plus 70 is 140. And then 180 minus 140 is 40 degrees. So that would be a quick way to finish up that question. Okay. Normally you won't see too many questions like this, a little too straightforward. We're going to get something more like the third one that's a little bit more complicated. So I'm going to go through that one now. All right, this one has a lot of stuff going on with it, but we're going to try to break up the picture as best that I can. So we have 2 triangles. We have a bunch of congruent marks here, and we're going to solve for all these missing angles just right on this picture. So you always want to start where you have the information. So I have the 46 here. So, and it's the only piece of information, or it's the only solid number that I have. I do have other pieces of information. So what I would focus on when I'm looking at this picture is I would focus mainly on this triangle first, because I think I can get all of my information here before I kind of move on, which does work. Because if these 2 sides are the same, then as we went over before, these 2 angles have to be the same. So I know E has to be 46. Now, once I know that E is 46, I can solve for angle B in this triangle. We can do 46 plus 46, and we will get 92. And then we can do 180 minus 92, which is going to give us 88. That's going to be angle B. All right, now, where do we go from here? We got this whole red triangle figured out. We have to find a way to kind of get over here into this triangle. So I already spoke about this in another video, but sometimes what's going to happen is you're going to have some vocabulary words that are not necessarily super obvious. So what I see here is angle D and angle E share this vertex. And this looks a lot like a linear pair to me. So what I can do is 180 minus 46, because I know that linear pairs have to add up to 180 degrees, and that will give me that angle D is 134. All right, now again, working through this picture, I'm now finally into this triangle here. So if I highlight that part of the triangle, we kind of ignore the other half since it's already done. What I will notice, or what you should notice here, is that these 2 sides are congruent. And again, that makes this triangle that we're working in an isosceles triangle. Again, if these are the 2 congruent sides, That means this must be the base. Now, if this is the base, then C and A have to be the same angle. They have to be congruent. So there's a couple ways to look at this. Since there's not a lot of algebra in this question, what I would do is I would take 180 minus 134, and I know that that's 46. So now I have 46 degrees that has to go to each of those angles because I know they have to be the same. So I would just take that 46 and divide by 2 and get 23. Right? There's another way to do this with a little more algebra if you want to kind of set up an equation. If this kind of intuitive workaround doesn't work for you, or it's very difficult for you to visualize, just let me know. I can go over the algebraic way to do this as well. But going back through this vocabulary, make sure that you understand the isosceles triangle, where the two congruent angles are. That's very, very important. And that rule that all three angles in a triangle must add to 180 degrees. That's also very, very important. All right, we got a ton of practice questions with this. You got your mastery check afterwards. So if you have any questions, let me know.